All right, now we're gonna be trying to implement the equations we developed before using that spreadsheet. I am using LibreOffice here, and the first thing we need to do is to put some of the to plug in the numbers for the different stoichiometric and kinetic parameters. For the yield here, I put it as 0.4 grams of cell per gram of substrate. For the half saturation constant, 2 grams per liter. For the maximum growth rate is 0.3 per hour. For the concentration of substrate in the inflow, 5 grams per liter. For delta T, 1, and for G, for the dilution rate, 0.2 per hour. Once we did that, we can create columns, one column for time, like I showed before, one for mu, one for delta S, one for S, one for delta X, and one for X. We start the time with time t equals 0. We're gonna give two values for S and X. We can use whatever we want on these values, and just putting that 2 here and 0.6. Once we did that, we start creating the first line, and the first line is basically for the time. It's going to be the time that we had before, so it's going to be cumulative plus delta t. So every time it's going to be the time that was before plus delta t. For mu, mu is going to be it's mu max times s over ks plus s. For delta S, it's the dilution rate D times S0 minus S minus X times mu that we calculated here over the yield times delta T. And delta S is just simply the value of S we have the time before plus the delta S we just obtained. For delta X, it's going to be so for delta X, it's going to be mu minus G. We're gonna put some dollars here times X, which is the X that we have before, times delta T, the time. So that's a constant also. And that's negative because mu is smaller than delta. And basically what for X is just the value of X we have before, which is 0.6 minus 0.003, which will give us 0.05. Once we finish this first line, we just copy it down as far as we want. And you can see here that the value of X start getting very close to the value we found before. We was estimated as 0.4, and same thing for S, which we found it was equal to 4. So it's very small little errors. We can graph these. We can graph X and S and see how they compare, and we can see a little bit better that so we're gonna get back to our board, and this graph here shows this is here the substrate in green, and this is the concentration of X in in blue. We started here, so the values for we have a secondary axis for just to allow to show both graphs in similar sizes. So we started 0.6 and we went all the way to 0.4, and here we started at 2 grams and we went all the way to 4 grams. So on top of that, what we also I also graphed here the concentration of S and X for different values of the dilution rate, and this will remind you of some what we did before. When this is the productivity, which is basically this is the concentration of X times G. If you remember, we developed a second order equation for G, and we solved to find the optimum, the G optimum, and we found that G optimum is very close to mu max, but it's lower than mu max. Okay, and you can see also here that as we're getting close to where G is getting close to mu max, we start having a washout. So the cells are basically we lose, and if you continue, we basically don't have any cells anymore. The reactor is gonna wash out. So that's really what I wanted to share with you. Let's meet for the next lecture. Thank you.